I'm not going to talk to my CV because I'd like to focus on the presentation, and let me just start going. So, however, just a small reflection. When I started university in the Department of Architecture here on this campus, and I noticed this just at the end of the driveway here, it was the old top floor of the engineering building, which in my year was the second year to convert from an engineering degree to an architectural degree. So it's quite fun to come back and to think. And when I completed the course in 1968 or something like that, I was the first person in the faculty to use the university computer, an NCR 350 or 520 or some code like that. And I did the most boring analysis of light patterns over Melbourne, which was some CSIRO data, and all my output was just contours of lighting levels. However, somehow it stuck, and I've always been interested in computing ever since, and PIM, of course, is a thing. But consider that was 1968, and now what, 40 or 50 years on, 50 years on, have we got very far? I'm not sure. Right, so I've got another interest. I study cuneiform tablets, the old Mesopotamian language, and I thought it might be interesting to reflect that in 1750 BC, right, 4,000 years ago nearly, here is the city of Babylon, and look at the scale of it, right? It's amazing. It's thought to have had something like 200,000 people in it at its peak, and at the time of this, it was the largest city in the world. And of course they used mud bricks and used very strange... I've got a tablet with a map on it, I'm not going to show you that. But we think we're doing great things today. They've been doing it for a very long time. So are we actually doing it better? 4,000 years later, are we doing it better? Are we really adopting new technology, or is it just a big political talk fest? And why do and I see in Han's presentation, we're all gasping in our seats on his budgets, the government commitment. What do we get out of Australian governments? Absolutely nothing, right? Absolutely nothing. So what's the opportunity? We're seeing the merging of what have been separate technologies, GIS and BIM, and other statistical and map type data is starting to be integrated. And this is leading further to the strength of BIM that was for buildings. And precinct modelling sits in this little domain here. It's a very natural space. A campus is a natural precinct scape. We don't really ever think of one single building. Even when we're designing one building, it's in the context of all the buildings around it. It's in the context of the planning codes and stuff like that. So precincts aims at a larger scale, and I believe it's actually the real substance of smart cities, not the political talk about IoT and advanced digital communication and information flowing backwards and forwards. What about the actual representation of our cities? And that's what it's all about. So a precinct information model is a series of interconnected databases storing all sorts of data across all the asset types in the environment, not just a single building-focused solution. And here's another sort of aspect of the whole process. Built asset modelling, which is what we're in. We used to call that building modelling, but we're really talking about multiple types of assets. And then the environment, all the maps, all of the other data that we traditionally associate with GIS. And here's the precinct scale again. We overlap into this GIS environment very easily. So I'm having trouble clicking. Please click. Here we go. So what is a precinct model? Well, first, we have to have a site. It seems the most trivial thinking, but how is a site represented? Well, normally cadastre, right? Do we represent cadastre properly in our building models today? No. And I'm going to talk about that quite a bit. Then we have all of the asset types: buildings, civil infrastructure, roads, railway bridges, tunnels, Open structures, landscaping, that's an aspect that isn't used much, that we need to focus on. Other sorts of structures in the landscape. And then we want to associate it with all of this administrative, statistical, ecological data. Why can't we get all that data into our models? It should be there. So part of the CRC for low carbon living integrated some information from the Adelaide team at Tonsley. We're looking at that ETWW project on embodied carbon, just taking up the theme of the last speaker. And how do we start that project when we build a precinct model of Tonsley Park? Well, first we go and get the PDF from the State Planning Authority. Then we find out that under those categories, the government's classified certain categories. You can see the codes and their definitions. And what we've done straight away was convert that into a digital document. Actually, it's in a BIM tool, and we export that in IFC according to certain entities that represent it. But why do we get from the council a PDF? Why can't we get a smart object that is the right-hand picture? Because if we got that smart object, here it is, it's now in my CAD system, my BIM authoring tool. Now we've implemented in Revit and ArchiCAD a little object which encapsulates all of this data, right? So we've only used Marion and Adelaide as two examples. We've done one for Sydney where we used 5 councils. But even if we took the whole series of councils across Australia, it would be a tiny textual database, right? It is so trivial. Now, mind you, we can't do that because the states don't have the same system. They have systems that are 95% the same and 5% different. And do they want to collaborate and have a national system? What would be the advantage of a national system? Oh, we all have the one common way of working, productivity, benefits. However, we select the zone type called, I always think sanitary when I read SAN. It's Suburban Activity Network. It's not quite the right thing. And then we find that those are the permitted uses allowed from that. So we've started a model based on intelligent data, and as soon as we choose things, we get the things that are allowed. And if we went a further step, we'd find that we could have those development types within that particular category, right? We don't have to go and look up anything. It's in a document that's on the web, downloaded in our machines, and we're starting to work. Now, if we went another step further, having chosen residential flat building, we could get all of the development controls for that. Now, that'd be a bigger document and perhaps a little bit more technically complicated, but trivial in terms of computing our knowledge today. So this is what we'd like to do. And then actually this is the Tonsley model that Woods Bagot did the original design for. And here you see an example of a precinct model. It's an early type of precinct model. And in fact, we populated it for the ETWW project with the residential capacity imagined by the planners, and it is clearly grossly over-planned. It can't possibly be developed as they've imagined it, which is the value of the BIM approach, the 3D visualisation approach, which is what we get. So what are the types of typologies? Well, there's the original Woods Bagot functional master plan, certain types of uses, all colour-coded. There's no height in it because it's not about the actual physical development, it's about the types of things we want on the site and how they're arranged. But the next stage, a built facility model, goes to more concrete form. The arrangement of the shapes is more purposeful. The asset types are more diverse. We've got an alignment for the road. We might have a water main going through it, blah, 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 all of the things that are needed. The next stage is what we call a traditional BIM model, elemental model, fully detailed, with all the information needed that Inhan and others have described in projects. And there's a final type called an occupancy model, where we populate it with the uses and the types of organisations that are doing it. So those 4 typologies give us a framework for creating a PIM model. And once we've done that, we can visualise it And all of this is IFC data. Everything you're seeing is IFC data here, open BIM data. So there's another point. Why are our government agencies not choosing open BIM formats? Why are they choosing formats that are proprietary software solutions? It's the wrong approach. If we're going to get innovation and productivity, we have to go to open standards. Now here's our second project of a PIM. This is the Broadway Precinct in Sydney. On the right is 2006 data for Central Park. It's now fully developed in many buildings there. Central Railway Station is to the right. And then you have the whole precinct of UTS, TAFE New South Wales, the ABC, and quite a bit going up towards the Ultimo extension. Now that data was converted from City of Sydney floor space employment survey data. They carry out every 5 years. They survey their entire LGA, and they tabulate the use of space, so the boundary of every floor, the spaces in the floor, the activity in the spaces, and the classification of the owners of the organisations that occupy those spaces. So why is that useful? Because they're trying to understand where development is happening, what the types of usages are as a forward planning criteria. Melbourne does this every 2 years, and I believe all the states have similar things in slightly different configurations. But the important point is that here we're representing this data in an open format, and that it's intelligible and it's also visualisable. Now you can do this in GIS. This is not an argument about whether GIS is better. It's an argument about what is the relationship between the design, the planning organisations, the design organisations, the construction organisations, and the users. And we forget that. And at the moment, the whole of the construction sector worldwide is going to BIM for the design and construction of facilities. So if we can't integrate those models and those data, we're wasting a great opportunity. Here's the classification. Now I want to introduce another topic, which is the Building Smart Data Dictionary. If we're going to get repetition, automation and reliability, we have to have a standard. We have to name things the same. If we call it a door in English, what do we actually mean? Because if you said a door in the UK, they'd think of a door set, whereas we say door. Whereas if you go to Holland, it's DOR with a slash through it. How do we represent those common terms? The Building Smart Data Dictionary is a smart way, multilingual, of capturing that definition. And we've implemented the Australian National New Zealand Standard in the Building Smart Data Dictionary, so that when you query your project or want to use a term, you can get to it quickly and accurately. So here's the Broadway model, a large number of buildings, I think 1,400 buildings or something like that. And here's an idea that's another PIM concept, a partial model, right? So you might say the block in the centre, which is building number 2 at Broadway in the UTS. Actually, it's been in the process of being demolished and being rebuilt. But notice on the left-hand side, the structure of the data, right? Everything has a relationship and we can search for it and we can understand what we're actually looking at. But at the bottom of it, we have to have a cadastre. So the cadastral data is literally the foundation of a PIM model. You've got to start with the legal ownership of the land, and we also have got to convert what in GIS world is called map grid coordinates, eastings and northings, to Cartesian ground coordinates in a BIM model, because one is a curved earth system and the other is a flat earth system. So I've recently convened an international project called Model Setup, which has made a robust definition of what's called georeferencing. So when you have a building model in your Cartesian ground coordinates, you have to make sure that if it's used in a map grid situation, you have a transformation. This sounds incredibly trivial. It is a tiny technical problem, but it's had worldwide support, because until this project has come to some conclusion, we haven't had this technical insight into the whole process. Despite the fact that surveyors know it, architects and building engineers don't. And it's a worldwide problem. It's not, it isn't just happening here in South Australia. So here's the problem about our map grid systems. If you're on what's called the meridian, and I don't know what, you're in zone 55 or 56, I think, or 57, I think you might be here. If you're on that line, that's where the distortion is the greatest, right? Where the word is most distortion. And you can be 40 millimetres in 100 metres out. So if you've got a project that's at the scale of Adelaide campus, this big block here, you have to have correction for the curvature. How do we do this sort of thing? What's the process of finding out all of the knowledge required? This is called an Information Delivery Manual, an IDM. It's part of the technology of Building Smart. And here we have the process model that is how industry works. Client commissions the architect asks the surveyor goes to the land authority issue a cadastral data, the surveyor puts it on the site, hands it back to the architect or the lead designer, and he then circulates that amongst his team. This process to date hasn't been so robustly defined, and that's what we're trying to do. So as a result of this project, we've got all the major CAD BIM vendors in the world implementing this small extension of the IFC standard, where geo-referencing is automatically included in your model, and the diagram top and bottom indicate the top one is the one from the map grid one from the from the land authority. The bottom one is the transformed design model, properly orchestrated, and all the data is captured in the interface there. Here's an example of how it's being used. So in Norway, the health authority uses OpenBIM exclusively. All projects are required to deliver models in OpenBIM format, and they then have a web toolkit for their facility management teams. For every hospital authority site in Norway, they have this available to their, this is internal use obviously, it's not externally accessible, but this is a map upon which transformed building plans from your BIM model are deposited, represented. So it's accurate and up to date. And it's a good example of how the asset management, how they are exploiting the asset management phase of the project. So this is the road. Here's another thing. So you would say, if I went to Roads and Maritime Services in New South Wales and said, can you give me a drawing of the roads around Broadway, they'd say, yes, of course, I'll send you a PDF in 10 minutes. They don't have any. UTS have no road drawings. We couldn't get any road drawings. We had to make it up ourselves from the cadastre. So that's the cadastre that's the road lot. It's not the road itself. So this is a tragic weakness of the current situation. Most authorities that own buildings have the most appalling records, and the quality of data is just outrageous. But here's our model that we bring in. We blow it up a bit. We did a little pilot on this building J at TAFE. TAFE managed to get their students to do a building model of this. We wanted to check the City of Sydney data against this is the City of Sydney information we're looking at, but we wanted to check the building model that the students did. Well, you can see it's not quite in the same place. So it's higher, it's larger, the space types are all wrong. So the quality of the data in the City of Sydney stuff is very suspect, but as a broad overview, it gives them a fantastic insight into the whole thing. So there is value in it, but how could we improve that value? We could improve it substantially if the council required that every new building should hand over a building model that satisfied their recording format for that. All it is a shell of the building and the classification of the spaces and the building owner. It's a tiny model, and it could be done so easily. So why don't they do it? Well, that's what we're trying to propose. So we asked a mechanical engineer to put in some building services for us, and there's the little building services model. Now this is all trivial and done in any normal major BIM project anywhere. There's a bit more going up in the roof. But now, here we are with a detail shot. We're looking at it in detail, and the green object there is an air handling unit. how do we connect that to the asset management system? Well, there we are, right? We have an ID in the asset database and we have an ID in the building model. It's all quite simple, except that what is this asset database? It's an Excel spreadsheet. It's an Excel spreadsheet. And about 300 of the descriptions in all of this air conditioning plant there is due to phase out of R22, recommended place in 1 to 3 years' time, right? So the people on the ground operationally have incredibly poor data. They're only focused on disasters. If the air conditioning fails, quick, go up and fix it. If they would have to do something strategic, it's almost impossible, right? It's almost impossible because they don't have the right type of data integrated in the right format to make it all work. Now, I was interested to hear Inhan's discussion about his code checking system, because on a previous project, Urban IT, before the PIM project, we wanted to do basics because we thought this was a good idea. So we looked at the website, and then we've implemented for the entire basics in 2008 or 9, I think it is. We converted all of the data into IFC entities. So we proved conclusively that we could represent it in an open BIM model, right? That was the first step, and it was all relatively straightforward. This is a little bit out of date, but largely it would work. We then put in this tiny little pilot building, and this is now in an IFC model server, the Jotny from Norway model server, and you can see the floor zones and stuff like that. But also we had to get specific data out for basics, and the first one was the address, right? Now, if you go and look at any building model at the moment, do they have the address and the cadastre in? No. So here's a tiny little innovation which would improve the quality of the data, and it's an example of the whole process. So there we are, right? Now we've the classification of the building. Do we have a consistent classification of buildings across Australia? Well, the NCC almost does, but it isn't utterly conclusive and could be much better. But again, we want to put that data into the BSDD so that we had one national place where you could get this information and access it easily. So we did a trial on that. Now, it's a bit technical, the BSDD, it's quite hard to use, but that's not the point. It's up to software developers to make it dead easy. I've compared this morning your metro map and the train guide in Sydney. If you want to see an easy guide to use, go use the Sydney one, because Metro Mate is not your mate, it's Metro Disaster. I could not get past button 48 or something. But what is the point there? Good software programming can solve anything. It's a question of being able to get to it reliably and make use of it. That's the whole point of our stuff here, making use of it. Here we are, one of the major things, and Vivian and one of the other speakers touched on this a bit. So in basics in 2008, there were about 11 wall types, I think. But CSIRO's done some excellent work which covers all it. And by the way, CSIRO's done the embodied carbon, not just the thermal performance or the other things there. But why is that important? Why shouldn't the government be supporting this type of activity more proactively? Because the whole of industry needs it for smart cities, smart buildings, smart design and construction. So our project had a very big focus on sustainability. How do you get all your data? And I think Vivian mentioned Bath database. That's the Bath database. It's not the Australian database. We looked at embodied carbon data sources, and the CRC had another project looking at this whole thing. There is none. There is none in Australia of comprehensive scope. And for the lady I was talking to earlier from precast concrete, there's a problem for the precast concrete people who are dead scared to get into this area, I think. Here's some work done by CSIRO. Fantastic. This is so valuable. It's so good. And it covers a large cross-section of residential stuff. How do we put it into a standard format in our models? There we are. We've adopted a European standard which has all the property sets, and hey presto, the data goes in the property sets and you use the BSDD and bang, you've got it. I've got to catch up a bit here. So there's more of this technicality. Now, so our developer is here and he's saying, we're using BIM, but the mayors are saying, well, how can we exploit all this stuff? Can we use BIM in our council offices? Well, I'm planning an office building. I go up into the cloud, I find my data, it comes in there, I discover that the permitted use in this particular selection of site that I'm at is so-and-so. There are the standard properties for it. What are the properties? Oh, well, there's the national embodied carbon database. It could be the national insulation database. There are the values. Don't have to think, it's all there. We can do a calculation now from the model. We've done a fantastic design. We save it up in our building model repository. Council says, what's on my agenda? Oh, here it is. How does that fit my plan? He wants to check that it actually fits the code. Hey presto, it gets the tick. I'm summarising, of course, but you understand the principle, I hope. So we've used smart technology, we use national standards, and we come up with much better opportunities. So my point here is this. We're so used to designing independently in a little siloed project team. Okay, we might share the models between that, but we're not getting council data, we're not getting other information from other authorities and people like that. So why can't we do a project? So InHun will be your partner in a DA submission project. And Melbourne City Council are very keen behind this, by the way. They've indicated their support for it. So we just choose the smallest compliance checking process, the DA assessment, right? It can't be that hard. And we've got lots of other things which I won't go into too much detail here because they're of a wider type. But the number of opportunities that exist to improve the whole process. So we would like to talk to a council about doing a PIM project. Just before the New South Wales government decided to amalgamate councils, we had a very good talk with Ku-ring-gai Council in the north of Sydney. They're doing some work at Linfield, which was a small suburban centre, a major bit of work. It would have been a perfect pilot for a PIM project. We need small pilots, not big ones. Chris Penn, one of my colleague at Building Smart, was the BIM manager on the new Royal Adelaide Hospital. It's too big. It's $2 billion plus. We want a project of 20 million where we can all get our hands dirty. If it runs over time, it doesn't matter. We all learn properly. The feedback's immediate. It happens in 6 months, not 4 years, etc., etc. So start small, choose the right technology problem, and I'm sure we can really do a much better job. So I believe, this is my last slide, we have an enormous opportunity here, and even just this group of people, you can see that there's a lot of commonality between us about what we might do. So that's it. Thank you.